Hi. Okay. Great. Okay, thanks. Oh,
Good morning. It's a nice day outside, hopefully a leading indicator for the state of the Indian economy as well. Um, my name is Chetan Ghate, and I'm the head of the Economics and Planning Unit at the Indian Statistical Institute Delhi Center. And on behalf of the faculty of the unit and the institute, I want to extend a very warm welcome to all our delegates to the 10th Annual Conference on Economic Growth and Development. It's been 10 years, which is a long time. Um, I particularly want to extend a very warm welcome to our three plenary speakers today, Professor Thomas Sargent from NYU, Professor Debraj Ray from NYU, and Professor Victor Lavi from Warwick. Thank you very much for coming to the conference. Just by way of backdrop, some of you may be first-time visitors, and some of you are repeat customers, I know. The Indian Statistical Institute was founded in 1931 by P.C. Mahalanobis. In 1959, the Indian Statistical Institute Act declared the institute as one of national importance, and the present campus that you are sitting in dates back to 1975. And the institute specializes in 5 key areas of research, and these are statistics, mathematics, computer science, economics, and operations research. This particular unit, the Economics and Planning Unit, has continued to work on the cutting edge or frontier of economic research, both in theory and empirical work. Research in mechanism design and auction theory has long been a strength of the unit. The links between education, health, and other public goods and the distribution of income has been a source of theoretical investigation. Social capital and collective action in the Himalayas, agricultural fires and air pollution, and the links between climate change and electricity demand in India are also some of recent empirical work coming out of the unit. I should also mention that research on schooling and labor force participation is an active area, as well as international trade and growth theory and empirics as well. This year we had roughly 350 papers, and there were approximately 138 acceptances. But at this juncture, I would like to acknowledge the singular efforts of one particular faculty member who year in, year out manages to make this into a great conference, and that's my colleague, Professor Trideep Ray. So can I please ask you to give a round of applause for him. Without further delay, we'll move directly to the first plenary speech, which will be by Professor Thomas Sargent from NYU. I will introduce him. It's my great pleasure to introduce Professor Thomas Sargent as the first plenary speaker. Since 2002, Professor Sargent has been the Berkeley Professor of Economics at NYU, New York University. In 2011, along with Chris Sims, Professor Sargent won the Sveriges Riksbank Prize in Economic Sciences in memory of Alfred Nobel, or the Nobel Prize. Professor Sargent is one of the most distinguished economists in the world today. He served as the president of the AEA, the president for the Society of Economic Dynamics, the president of the Econometric Society. He's a member of the National Academy of Sciences, he's a fellow of the Econometric Society, and is a fellow of the American Academy of Sciences. If you're still not impressed, he's been a first lieutenant and captain in the US Army in the late 60s, where he worked at the Pentagon. And if that doesn't cut it for you either, his Berkeley graduation speech was just 365 words, according to his Wikipedia entry. Professor Sargent's contribution has been gigantic and continues to produce path-breaking work. He is closely associated with the rational expectations revolution in the 1970s. His paper on the unpleasant monetary arithmetic spawned an entire literature on monetary and fiscal coordination. He's done seminal work on inflation and understanding the persistence of European unemployment, what he calls the European unemployment problem. He's made seminal contributions to the field of time series and to robust optimal control. He is the author of more than 170 research articles and a dozen books in a career spanning several decades, the recent titles being Recursive Techniques for Dynamic Linear Economies and work with Lars Peter Hansen on a book called Robustness. What's unique about Professor Sargent is that he's given equal attention to the construction of models as well as their confrontation with the data. And for all these reasons, he is considered one of the fathers of modern macroeconomics. So without further delay, let me ask Professor Sargent to come to the floor. Thank you.
Thanks. Yikes. I hope we get rid of this fast. What do I do? Help. Now what do I do? Okay. That makes me feel better. Okay, great. And then I do this? What do I? Good. Okay, good. So it's a pleasure to be here. Especially a pleasure because one of my best colleagues at NYU, Debraj Ray, who's a fantastic economist, used to teach here. And then also I have had students who at NYU and elsewhere who used to who learned here. And I must say, I love being in seminars with Debraj. And maybe it's good he's not here because he thinks some of what I'm going to talk about today is crazy. So, and he speaks up. So my topic is going to be, I'm going to describe some joint work with Lars Hansen that I'm doing. I'm going to talk hopefully fairly precisely about an imprecise subject. And it's actually a subject that so various people thought it was important and failed to do anything with. So many people have told me this is a dead end. So you're going to see what we're talking about. It's also going to be related to some questions I got yesterday from some very smart master's students. So it could be titled this: Risk, Uncertainty, Value, and Public Policy. The risk uncertainty is going to be a distinction between, I guess what Frank Knight called risk, ignorance about, ignorance that could be just nevertheless described by a known probability distribution, versus uncertainty, which is a more profound kind of ignorance. I need my slides. Okay, good. Okay, so the way my friend Lars Hansen would describe this is, I'm just going to talk about uncertainty within economic models. The title of Lars's Nobel speech is Uncertainty About and Within. So I'm just going to talk within. And I'm going to be talking, so within economic models there's going to be people like us. Or are they like us? So after hearing a version of some of this material, Bob Lucas came up to me and he said, why should the people in our models be like us? And I told him, my answer was, you of all people don't get to say that. And so we're gonna talk about that. That's going to be the heart of it. Okay, so here's what it's going to be. So this is about doubts. It's all going to be about doubts. Lars has a quote in French. And I don't read French. I don't think he does either. So there's something about Shakespeare. It's about doubts. And here, what the doubt is going to be about models. I have to tell you those terms. So I'm going to talk about, here's the roadmap. By the way, I hate slides. I'm pre-slide. If you're, I'm a pre-slide person. We used to use the blackboard. So I'm going to talk about uncertainty. So the roadmap is, what is it? Why do we care? How do we represent it? How do we measure it? Who confronts it? How does it affect equilibrium concepts? What does it do to quantities and prices? And how does it affect the design of good government policies? And that's a subject of this monograph Lars and I just published. Okay. So I'm just going to go through. What is it? It's fear of model misspecification. Okay, so now I have to tell you what a model is. Okay, so this is my seminar. This is my definition. So a model is a probability distribution over a sequence. That's what a model is. Otherwise known as a stochastic process. So think of a sequence of prices, quantities, all other stuff. That's what a model is. So I'm going to have a digression about rational expectations. So a rational expectations model, this is about communism, is shared by every agent inside the model. There's a circularity there already, by nature and by the econometrician. So that's a communism of models. There's a unique model that's shared by all those people. People may have different information, but they have the same model. What's a model? It's a probability distribution over a sequence. Now the reason I ask you this is I taught a class at Stanford in macro, and every day I came in at the beginning of class and I said, a model is a probability distribution over a sequence. And I said an agent is a constrained maximization problem. In the midterm I put, what is a model? And it was very depressing reading it. Half the class missed it. So the key thing is the sharing by the agents, by nature, and by the econometrician. That's heavily exploited when you do GMM or maximum likelihood estimation of a rational expectations model. You are using that. Ariel Packus or Diner or any rational expectations econometrician or Lars Hansen or Hansen Singleton, they use that. When they write 1 over t summation something converges to E, they're using that heavily, all over the place, every aspect of that. Now notice the following. The sharing with nature part precludes concerns about model specification, and it precludes any treatment of belief heterogeneity because of the communism. That's built into rational expectations. In game theory, that's called the Harsanyi doctrine, common priors. Now some of my friends and distinguished theorists take the Harsanyi doctrine, and common priors is the only way to go. If you read David Krebs's notes on the theory of choice. He notes the widespread acceptance of the Harsanyi doctrine, and he timidly says he doubts it. But we're going to come back to that. Okay. The sharing with nature notion is used widely in finance. If you think about finance, they're using it very widely. Okay. So here's another way to think about this. I want to think about a rational expectations model as a fixed point in a mapping from a set of beliefs about sequences, random sequences, to what the random sequences actually are. So it's a fixed point in a mapping from a set of perceptions to a set of real things. That's what a rational expectations equilibrium is. That fixed point is the communism. Okay, that's enough said. But you can't talk about misspecification. Okay, so when I say what is it? It's fear of model misspecification on the part of somebody. And the part of the somebody that I'm going to have is the agents inside the model. They're going to, so here's the story. Lars and I are econometricians. We build rational expectations models. We work hard. And we fit them by maximum likelihood or some Bayesian method. At the end of the day, if somebody asks us in a seminar or after seminar, do you really believe that model? Or they ask Prescott, you'll say no. In a discussion like that, it's an approximation, it's the best we could do. Somebody will then say, well, what's an approximation to? Why didn't you write the thing it was the approximation to? And we should say, we have no idea about that. So as soon as you say approximation, you're departing from the interior communism of a rational expectations model. Okay. So the question is, why do we care about fear of misspecification? And we have two reasons. I kind of told you one. One is the Ellsberg experiments make the savage axioms dubious. So at lunch yesterday with, or pre-lunch with some Delhi School of, this is probably illegal what I did, because we did an experiment with human subjects, and I'm not entitled to do that, but we did the Ellsberg experiment. Once again, savage axioms failed, but they behaved according to some other axioms, which might. So there's savage axioms that say people don't have a unique model. But then the reason Lars and I care is it's statistically difficult to distinguish alternative models from the samples we have. And that puts an econometrician always on thin ice with respect to having complete confidence in his model. Remember, what's a model? Okay. So here's the. I'll move on to the next question. So why do we care? So Lars and I care. That's why, because if you actually build a model, that's a good way to acquire some humility about it. Okay. So how do we represent it? Okay. So we're going to follow. We're going to use procedures that they're common. They amount to a common set of procedures, but they come from different ways, different sources. We're going to. Lars and I got to this from the mathematics of robust control theory. But there's decision theories that come from the Ellsberg, Gilboa, Schmeidler tradition of multiple priors models that get to something quite close. So Lars and I are going to represent fear of model misspecification as a decision maker who doesn't have a unique model. He has a set of models, which he refuses to reduce to a single model by the Bayesian device of putting a prior over the set. If I put a prior over the set, then I've got a single model. So the discussion would go like this. So my friend Chris Sims, who's a religious, committed, fundamentalist Bayesian says that any smart person who's not lazy and thinks hard enough can always reduce a set of models to a single model by putting a prior over it. My friend Lars would say to Chris, oh yeah? I don't want to put a unique prior, I want to put a set of priors over the models. And that discussion can go on. So the profound thing is that our decision maker doesn't know enough to put a prior. Okay, so this divides people. Like Leo Hurwitz, so very smart people have different opinions on this. Leo Hurwitz, a great economist in Minnesota, who he knew all the people who founded decision theory. He wasn't a Bayesian. And he always said, the way he put it very politely is, it's impolite to ask a Bayesian where he got his prior from. That's what he said. So, but he did not use, he resisted being a Bayesian. And my friend Neil Wallace, who rarely does empirical work, rarely does empirical work, he says being a Bayesian is the only thing you can be, and it was a fatal mistake on Leo Hurwitz's part not to be a Bayesian. So this divides really smart people. But so Lars and I are going to, we're going to represent it with a set of models that you can't put a prior over. And if you ask the guy to put a prior, he's going to put a set of priors, and it's not going to, that's it. Okay. So now the question is, how do you manage it? Now you're going to see a continuous commitment of Lars Hansen to this philosophy, or Ravi Jagannathan too. So how do we manage if you don't? So think about calculating expected utility. Expected utility with respect to what distribution? If you have a set, how are you going to rank things? So if you know about the Hansen-Jagannathan bounds, or you know kind of the philosophy of semi-parametric statistics, you're going to try to get bounds on things. So we're going to construct bounds on value functions. So how do you construct bounds? I'm trying to talk you into something that like Chris Sims is going to say is ludicrous. Okay, how do you construct bounds? So our tool for constructing bounds on value functions is min-max expected utility theory. That's what we're going to do. That's what robust control does, and that's what I think of it as Gilboa-Schmeiler Italian-style, they call it ambiguity-averse decision theory. So there's going to be a set of models, and the way we're going to construct bounds is we're going to imagine a two-player zero-sum game. So I'm interested in maximizing my expected utility, but I don't know which distribution. There's going to be a set of distributions. It better not be too big. It's going to be a set of distributions, because I don't know which model is governing things. I'm going to maximize expected utility, assuming that nature is minimizing me. That's, by the way, the Gilboa-Schmeiler thing that explains the Ellsberg paradox like a charm. So that's what we're going to do. So now you could say, boy, you're nuts. You're neurotic by thinking that nature's, whatever you do, nature's going to pick the worst case. And you can play the Nash equilibrium of that game. But that's not, you don't really think that that's what's going to happen. That's not why you're doing it. The reason you're doing it is you want to construct bounds, and you want to, by doing this, it's going to turn out, you're going to discover where your decision rule or where your way of evaluating things is fragile with respect to details of the stochastic specification. It's all about bounds. So another way to say it is, I'm going to construct a decision rule that's robust in the sense that as I move the probability distribution, outcomes don't change too much. So this minifying player, he's actually your friend. He's asking you, maybe you shouldn't be confident that that decision rule, which works really well against your model, is actually going to work that well. You should think about perturbations. Okay. And if I have time, I'll give you some examples. Okay. So how do we measure it? Okay, this is, actually, I hang around macroeconomists who are very easy to scare. You could scare them with a complex variable. And you can scare them with this. How do we measure it? We're going to use relative entropy. It won't scare an econometrician. What relative entropy is an expected log likelihood ratio. There's two distributions, two models. So what that is that's a statistical measure of model discrepancy. It tells how difficult. It tells two things. It tells how difficult it is to distinguish two models, and it bounds rates at which you can use more and more data to distinguish the two models. So it's a natural concept that emerges in information theory and econometrics. That's what we're going to do. Okay, so look. So I said, maybe you got frightened. Look what Shannon said. Shannon and Lavoie. So when I think maybe this is true, maybe it's not. When Shannon invented his quantity, he didn't know what to call it. So von Neumann told him, call it entropy, because it'll scare the hell out of people. That's basically what he said. So he called it entropy. And actually, if you look at it mathematically, it's exactly what Boltzmann had in it. Okay. So now, how do we measure? The question is, how do we measure? How do we measure model uncertainty? So here's the deal. We're going to imagine you just like in a standard rational expectations model or something, or you have a model, and you have a single model, and it is your model, but you just don't trust it completely. So what you're going to do is you're going to surround that model by a whole set of other models, they're going to be mutually absolutely continuous. And that means likelihood ratios are going to be well defined. The reason we do that is that means they're going to be statistically hard to distinguish. If they weren't mutually absolutely continuous, there would be some events that occur with one model that can't occur with the other. They're easy to distinguish. But if that likelihood ratio is not, infinity or zero, entropy is going to be well defined. So here's my model. I'm going to surround it with an entropy ball. And I'm going to choose the size of the ball so that it's plausible that any one of these models could generate the data. So I don't know. So Lars and I have done this. Okay, you estimate a model by maximum likelihood. Along certain dimensions, the likelihood function looks like this. Doesn't quite have a ridge, but it's very flat. So that's telling you that these models are close to this model. Okay. So that's it. So we're going to have an agent who is going to make decisions with this set of models in mind. That's it. So now the question is, who confronts model uncertainty? You notice this is either heresy or refinement of rational expectations. Because in rational expectations, there's a unique model in everybody's head. Every agent in the model, God, and the econometrician. So here I'm just talking about the person, like Lars and me. So who confronts it? Well, we the model builders do. But now here's the line with Lucas said, who said, why should the people in our models be like us? See, remember, John Muth's original paper is, we should make the people in our models at least as good as us. So that's why Lucas doesn't get to say that. Okay, so actually, if he were here, he'd be mad at me for two things. All this stuff about communism, how could you say rational expectation? How could you say that? And then also the stuff I did. Anyway. So, but the agents inside our models, we're going to make the agents inside our models have a model, but they're not going to completely trust it. That's the idea. Now, this goes back to the origins, before the origins of macroeconomics, because that's Keynes's PhD thesis. He said that people don't, treatise on probability. It's exactly this. People who make economic decisions don't use probability models the way you think. So this is going to be a cut on that. So we're going to have private citizens